Hi, my name is Aliot the Shotgun, freelance camera operator and colorist, the founder of Shade and Grain.
In this episode, we're going to talk about our first topic, basic of light. Before we begin, this question might run through our minds. Can someone who's a beginner understand the color theory? Or maybe it's just something complementary? Do we really need the color theory, or it's just something that's cool to know, but it's not so practical? It's true that some discussion of color theory are very advanced and can be very technical and complex, the core concepts. However, the things we need must, as a beginner, involve a few simple basic ideas about light. The answer is yes. We need to know the color theory and we will find the practical application of it. So let us begin. We know as well, if we turn off our screen into a dark room, we will not be able to see any colors. In fact, we cannot see the screen or a cell phone or whatever we're using either. That's so clear, we need light to make things visible. Our eyes need light to see the shapes and colors, and it's important for us to understand that color depends on light. Now we know that light is the basis of color theory, we must know that light is a form of radiant energy. Radiant energy is the physical energy resulting from electromagnetic radiation normally observed radiating from the source into the environment. Fields in which this terminology are most often used are telecommunication, heating, radiometry, lighting, and a term of energy created from the sun. Radiant energy moves through space with an undulating motion. We also know them as electromagnetic waves. These electromagnetic waves move in straight paths called rays. These rays have long and short waves. The spectrum of the frequencies of electromagnetic radiation extend from very low values over the range of the radio waves, television waves, and the microwaves to visible light, and beyond to substantially higher values of ultraviolet light, X-ray, and gamma rays. Don't get confused, let's continue. The measure of the distance from wavecrest to wavecrest is wavelength. Wavelength is usually denoted by Greek letter lambda. It is equal to the speed of the wavelength of train in a medium divided by its frequency. In the other words, the number of wave crests passing a given point in a given time is called frequency. But we'll not solve mathematics and physics here, we just want to have a better perspective on the light concept. So, what we know? Light is a radiant energy that travels through space with an undulating motion. Rays is a straight path with an undulating motion, or electromagnetic waves. A wave is disturbance that transmits their energy through matter or empty space. In our case, wave is the motion pattern of light, or in the other words, straight path of the wave-like motion. Wavelength is a measure of the distance from wave crest to wave crest. Frequency, number of the wavelength passing a given point in a given time. If we make a diagram which all rays ordered by wavelength or frequency, we get a picture of the electromagnetic spectrum. The rays in a spectrum differ in the length of waves, frequency, and what these rays do. The electromagnetic spectrum is composed of visible and invisible rays. Only the visible rays in the middle of the spectrum are called light. Light can be defined as the form of the radiant energy that is visible. In other words, the eye and the way it sees light is fundamental to our discussion of colors. So now we have a perspective on the light that is brought to us by the sun, but it's not the end of the story. The visible part of the electromagnetic spectrum is composed of colors. The easiest way to see it is to observe what happens when a white beam of light passes through a triangular lens called a prism. A prism bends the rays of white light at different angles, so that the white light is divided into rays of different wavelengths. Each wavelength gives the eye an impression of the different colors, a color pattern like a rainbow: red, orange, yellow, green, blue, indigo, and violet. Isaac Newton showed that white light is a combination of the full color spectrum and has both optics in 1704. The colors in this pattern are always arranged, so that red is at one end, orange, yellow, and green are in the middle, and blue and violet are at the other end. We'll discuss about it in our color history section. But here we need to know that passage of time also has a great influence on what we'll know and learn. For example, Newton's blue could call turquoise in English since decades after him. In French, even earlier. If you had a second prism to let the light through, the colors would reunite it into a white light. A prism does not create or destroy the colors. It merely bends the light and scatters the colors apart so that we can see them side by side. For example, when the sun shines on the rain or after the rainstorm, raindrops act like a tiny prism, breaking the sunlight into its individual colored parts. We can achieve the same effect yourself with a garden hose. Stand with your back to the sun and spray a fine stream in front of you. If you spray the water in the direction opposite to the sun, you will see a rainbow. So what we know, only visible rays are called light. White light is a mixture of colors. A prism bends the rays at a different angle, so that white light is split into a rays different wave. Raindrops can act like a tiny prism and bends the light in nature into a color pattern called rainbow. The most common sources of white light is the sun. Other sources are fire, candles, and artificial light that we produce on ourselves, such as electricity, etc. The light from one of these sources does not appear to us as a particular color. We are not aware of the colors mixing because it's a mixture of the many colors of the visible spectrum. Each light source has a slightly different mixture of the color rate. Therefore, color objects look different under the different lighting sources. This is especially important for photographers who use this information every day to adjust to different lighting situations. For example, the sun is the balanced mixture of the rays in visible spectrum. The light of a light bulb has more red rays than blue. The light of a daylight lamp with a fluorescent tube has more blue and yellow rays than red and violet rays. Rays of light from any source travels all directions. Some of these rays strike the object we are looking at. Some of these rays bounce off the object and are reflected back to our eyes. Only the light that reaches to our eyes penetrates the light-sensitive cells that are sent messages to our brain. Human eye is very similar to a camera. It has a lens, a light-sensitive layer called retina, an eyelid that acts as a shutter. Although we don't know everything about how we see the colors, we do know the human vision refers to three colors: green, red, and blue. Research shows that the brain converts the wavelength of light into a color sensation, depending on the nerve connections and the brain. So a mixture of the same portion of the three colors, red, blue, and green, gives the white light. We understand if you have light, we have the color. A mixture of colors, but it depends only on how warm and cold the light is. Here we can say that we learned how the light comes to us, or to our eye, how we feel the light. In the next episode, we'll talk more about colors, different ways to create color, primary and secondary, even more on RGB, reflection, transmission, and subtraction. Thanks for watching this video. I hope it was explained clearly and simply. In the description below, I already prepared you guys some questions to answer. In the next video, we will review the answers. If you have any questions, feel free to write me. I'm also working on some videos about color correction and color grading, so I can share my experiences with you. So, if you like this video, don't forget to subscribe and even like it if you find it helpful. And of course, you can share it with your friends. So until the next time, see you in the second episode, filtering the light and color. Enjoy the color.